is a transformer with the primary side. You can either input 400 or 230 volts. And we've got two windings on the secondary side of 115 volts each, and you can link them together to make 230. So what we're going to be doing is using it at the moment anyway in 230 volt mode as an isolation transformer effectively. So we've effectively got 230, normally 230 volts in and 230 volts out that provide an isolation. Okay. The maximum current in the secondary that gives us the rating is 0.43 amps. So we need to bear that in mind. We do a short circuit test, make sure we don't exceed that in the secondary winding. Okay. What we're going to do is carry out open short circuit test. Determine model of transformer. Use model. To determine and we're in that we'll find I terminal volts, yeah, secondary terminal volts. These are not necessarily in the order we'll find them, by the way. We'll find the core losses as well, so we'll have a reason for. So all we're going to do now then is run the practical transformer and record the results in here. So we're going to apply a primary voltage of 230 volts in open circuit mode. We're going to measure the primary current, the secondary voltage at the terminals, and how much power we're inputting using a wattmeter. We'll then short circuit the output, slowly increase the input voltage until we're around about 0.343 amps, so that we know we're not going to overload the system, and then we're going to record what primary voltage, primary current and power in is in short circuit mode. Alright, so that's what they're going to do. Right. So, for the benefit of anyone watching the video, practical results are thus. So applied 230 volts primary voltage to the open circuit transformer. Primary current is 33 milliamps. Power in was measured at 3 watts, and the secondary voltage at the terminals 251. And the apparent step up there is where the designers of the transformer have overwound the secondary to account for the losses, so to try and get this to deliver 230 at the secondary when it's fully loaded. We'll see whether that's apparent when we analyse it. And then the short circuit results. So we short circuit the output, turned up the power, or turned up the voltage on the input side until we got 425 milliamps secondary current. That's just under the maximum rate in the transformer. At that point we measured the power in as 8.2 watts. The input current was 465 milliamps, and that was at a primary voltage of 25 volts. So the idea now is that you develop the simplified model of that transformer and find out what the secondary voltage is, secondary current, power dissipated in the load, as asked for on the previous slide. So this is what I'm asking you to find, and we'll modify this with a load of 500 and what was it, Keith? 564, I think it was, wasn't it? With a modified load of 546 ohms resistive. Use your model to find, with a 230 volt input voltage, what the power dissipated in the load is, the secondary terminal voltage, the secondary current, and from the short circuit model find out what the core loss components are. You could also do efficiency, which is P out over P in. What we'll do is you'll finish off that model today. If you haven't finished it, finish off during the week, and we'll start next week by reviewing this practical and seeing how close it is to what we actually get on the instruments. So we'll leave that connected up, just put the instruments away. We can whip it back up next week and actually run that up and see whether your model predicts what we get on there. Don't expect they'll be very far out.